Welcome back, dear friends. Another day, another exciting load of jobs to do with the Gregorian scribbler, date writing machine. And today I thought, let's find an excuse to add some more bearings. I don't know what the current count is. It's in double figures, I'm sure. But look, here's the scribe, the writing thing. I've glued the titchy little magnet. It's the size of a grain of rice. It's amazing. Into the end of the stylus, so the overall effect is, look at that, isn't that amazing? So it pulls all the iron filings that are suspended in this thick, well, this viscous, white, opaque white liquid that's in each of these little honeycomb cells to the front. And because it's so thick, the little particles just stay there, unless you get something on the back. Like so. I can't use the built-in magnet because this is all geared on, but if I wipe this across the back, look at that. Isn't that amazing? As if by magic. And that's what the hidden thing that I made last time is, this mechanism under here. That's all to lift this little piece of magnetic strip up, so as it rotates it can erase yesterday's day, date and month. And then of course, because this needs to be as precise and accurate as possible, I can't have any slack, any wobble. Hence the fact that this has got two more bearings, one either side, space in the middle. That is going to fit in there, and it can't wobble that way and it can't wobble anyway, which is great. It's what we want. And it will then point, these are going to have the letters in for programming it. If you want to set the time, date, year, change it or whatever, it's got the real-time clock in it. Well, it will have. So it shouldn't be necessary. I haven't had to reset mine since I built it about 4 or 5 years ago. It still keeps perfect time and date and everything. But if you do, so the stylus, then you can use that like a multi-purpose thing. It'll then point to one of these things to tell you which setting to change and the settings around the edge. So as you turn the wheel, this moves round so you can set the respective things. It is so complicated. I have absolutely no idea how I managed to program this, right, the Arduino sketch. And it does fill me with a certain degree of dread because it is so complicated. But logic dictates the fact that I have used this sketch in the last ones I've built, and it's always needed a bit of tinkering, I think just because of slight mechanical differences and the complexity of it all. Hopefully it'll work. Fingers crossed. Now for the control knob, and here we have one that I prepared earlier. It's a lovely gate valve, brass and loveliness and red bits, and I've taken the inside, the thread out, and replaced it with an amazing little encoder, which is a switch. There's two switches in fact, and as you rotate it you can feel it clicking. If you've probably got a car radio or something, when you turn the volume or the control knobs on that, you can feel them slightly clicking, and they keep going round and round and round. Well, that's probably an encoder. And one of the switches inside switches on and off before the other one, and that allows something like an Arduino to work out which direction you're moving it in and how far it's been moved, which is fabulous. With my vice-like grip, I've got it apart. There's the base that's got lots of room inside it once you've taken the gate bit out. And there's the works. You can see the encoder's really small. It's that little thing there. Focus. So what I'm going to do, because I've designed these little bits and pieces to fit inside this, well, you've got a ring-size seat. I'm going to stay well clear of this. There's a very long parting off tool, and this is supported like so. Phew, that was a bit nerve-wracking, but there it is. So we've retained the bit that's going to support the encoder, and we've got rid of the other bit, and we'll always find a use for something like that, because it'll still fit 15mm pipe in. There's 1,000 uses around the home. Right, let's get this cleaned up and we can get it all fitted together. Let's talk labels. Labels look fun, but they're actually really difficult to design. It's interesting how long they take, especially when you've got sort of funny ornate shapes that you need to fit in amongst a machine. I've set the red letters, red, to engrave, which means it goes backwards and forwards very fast, switching on and off as it goes, like when it needs to actually burn off the thin white layer from the top of the engraving laminate. And then after it's done that, it'll cut out the outer bits with the black, with a standard cut. I've cleaned them up with some isopropyl alcohol to get rid of the soot. And look, isn't that lovely? Oh, I just love it. And I was thinking, oh no, how on earth am I going to line these up in these little recessed laser engraved parts? Because they're circular. And I suddenly thought, a short piece of sellotape. And sure enough, blob of super glue behind each one, can see to line it up, push it home. Perfect. I thank you. You would not credit it. This wretched encoder. Wretched, wretched, wretched. There wasn't enough thread on it to actually fit and tighten it through this ply and the laser engraving. So I thought about all sorts of different things and decided to just drill a hole, 30mm diameter hole, halfway through the ply so that the nut would then fit. But the nut was so badly made that it still didn't take up the thread, and I couldn't get the encoder to fit in because it kept swirling round and twisting and that and that and the other, and then it wouldn't tighten up because the encoder was getting in the way. It's 2 hours later basically, so I ended up making all sorts of spacers and little bits of plastic to try and hold the encoder in place. All failed. In the end, just sort of cut the back out and somehow managed to get it done. And in the process, of course, managed to break the reed switch there because it suddenly flew apart. So I had to put a new reed switch, bending it to shape, and it flew off onto the carpet of invisibility. I've been crawling around for about 10 minutes. Luckily, I had one left, one reed switch. So that is all I have to. Oh, and then I scratched the metal, the red paint on the front when I was trying to tighten the nut on the original one. Luckily, I had a spare. You would not believe it. What a pain. But that is now done. Now I'm going to look at making the little windows. Overly complicated, of course. They've got a series of mesh and all sorts of things. There's a whole load of stuff that goes to make them up. But when they're held over or supported over the 4 little flickering LEDs on the stepper motor interface, it gives the impression of movement, especially with some gears, a little silhouette of some gears and things cut out. It makes it look like a part of the machinery. And by the way, this is one of those great finds when you spend 5 hours hunched over a hot computer googling stuff. It's a rivet for jeans or fashion items. It's got another half to it, and they come in all sorts of different sizes, but it looks absolutely splendid and makes a perfect window. Let's get on and cut out the myriad of parts that we now require. Well, here are the bits for each of the displays. There's the gears, discs, some rings, some other bits, bobs, some tracing paper, and I've also got to cut out 2 discs from this lovely stainless steel mesh, but I have absolutely no idea how they all fit together, and every time I build one of these I have absolutely no idea and have to spend some time fiddling, but it's an interesting puzzle. This time, however, I've got my pencil and copious notes at the ready, so I'm going to make copious notes. And there we have 2. There's the bit on the back that acts as to create the silhouette, and then if I hold this up to the light, then you simply push that through the piece of wood, glue that in there, and there you have a lovely interesting little window. Let's broach the potentially embarrassing subject of plumbing and electrotrickery. Not generally a very good mix, but with steampunk machines we need to. When I was designing the first machine, I realised, I think it was a barognetic prognosticator, I was thinking, how can I hide the cable to it, the power supply, 5-volt power supply. And after lots of umming and ahhing, thinking about chiselling holes in walls and things, I suddenly thought to myself, the Victorians would have been ever so proud of their engineering and would have wanted to display everything, including the source of power. And these shower hoses that you can get, antique shower hoses, are perfect for that. Because you can take the rubber pipe out and it leaves a really nice flexible tube which can contain wires. The wires I use, and I've just realised I haven't got any, so I've just ordered some more, in the UK are 5 amp twin lamp shades, standard lamp fittings, low power cable, because you've got the two cores inside for the positive and negative, or positive 0 volt 5 volts, and it comes in an oval, usually outer covering, which, I mean, the inside of this is pretty smooth, but just being cautious, it just means that I know that it's all protected nicely inside. Now then, you've got this, you've got a wire going through it, but you need some way of joining things up. What I discovered was, and this I was going on about it last time, bemoaning the demise of poor old Maplin Electronics, where I used to get these from, I was so pleased to find the identical ones available at CPC Farnell in the UK. Lots of Googling later, obviously. There's a female plug, if you get me drift, and there is a male socket. So they fit together. And they also come with this, but we want to discard all that, because what I discovered was, if you take this bit out, it fits perfectly in one of these plumbing fittings. And then these bits fit in this type of plumbing fitting, which I can't remember the name of. This is why I'm always concerned slightly about putting the camera on, because when it's off, everything goes beautifully. You put it on, and then it's a sort of, well, dicing with disaster. Look, it just sits beautifully. Isn't that gorgeous? It even uses the little ridge inside that stops the copper pipe from pushing in too far, just to rest on. And the contacts inside don't stick anywhere near the edges. I'm going to put heat shrink on them anyway. I was so thrilled to discover that. That's perfect. I can glue that in with some araldite, epoxy resin. Now, let's have a look at this. Because I seem to remember that if you do that, where are we? Here we are. Like so, the nut doesn't go far enough to do up, because this flange here, if that flange wasn't there, that would be perfect. And I remember, now I'm thinking about it, having terrible problems trying to get rid of this flange. I've just had a cunning plan. Use a drill bit. Before, when I was trying to use the the lathe cutter to cut this off, this was flashing around, and because it's quite malleable copper, it would almost cut through. However carefully I did it, and then rip suddenly and bend the whole lot out. So, safety goggles on, let's give this a go. I say, governor, it's so satisfying when, after having got it wrong, or doing it in all sorts of different ways for ages, you suddenly come up with the perfect way of doing it. That is absolutely a joy. The bird, and that's got a ridge on it, so that just sits like that. Now let's see if this does indeed work. So that goes like that. Oops. This goes like that, and that goes like, there's the prong there, and then, oh look, dear friends, I'm absolutely thrilled with that. I'm so pleased to have found another source of these lovely sockets and plugs, and to have worked out how to cut this. Just, oh, what a joy. the time that I spent trying to figure out how to cut off a drill bit. Right, I'll get wires fixed on and get... In fact, no, the reason I'm doing this is to prevaricate, because I'm slightly wary about uploading the software and seeing whether the scribbler works. So I've now found a new thing to do, which is to make these two, get them glued in so I can get power to the thing when it's actually ready. Yes. Well, I've got them paralleled up, so I can have one supply coming in, out, and it takes off two for this bit. Let's just heat shrink these down without setting fire to anything. I always find that so magical. It's amazing. So that's now really well protected that. The other reason for using heat shrink is that when you solder a piece of thick wire onto like a pillar or something, you have to bear back the insulation obviously, and then you clog the end up, or stick it on with solder, basically solder it on, and it leaves a small fraction of space where all these bits in fact, so you're left with a teensy little fragment of wire where you've got the separate strands, because this is flexible and can be moved lots of times, just like normal standard flexes, because all the wires, the individual strands, can ride over one another. But once you get them fixed, you've got all this force twisting constantly, really prone to snapping there. Hence the fact, if you put some heat shrink sleeve over it, that gives it the rigidity necessary to stop it snapping off. Now I can put some araldite in there and glue these in. Right, the glue's setting with those two. There's the link inside the loop, and then there's a separate positive plus 5 volts going via a fuse. The scribbler draws a maximum with all the motors going of I think 330 milliamps, so that's fine. And then a nice bit of Vera board. So I've got a place now that I can put all the positives, of which there'll be far less than the negatives, or ground, 0 volts there. And then that just goes back down to here. Thank you. I think it's time to start wiring things up. Voila! The wiring is done. Got the wires from the back of the encoder and those bits coming together with some of this lovely spiral stuff, which I must order some more of, so run out of that. And then all the grounds going to that side of the Vera board, and all the reds, not many of them because of the way the circuit works, going to the positive side. And then all the lovely wires coming down. Isn't that nice? Hopefully all to the right places. The only thing I haven't done is to be able to connect these two up, which are the SCL and SDA, said he, cheating, reading off his notes, which will go to the real-time clock, because I haven't got a real-time clock yet. I thought I had, but I haven't, but I've ordered one. This shower hose is absolutely brilliant. As you can see at this end, it did have a captive nut. Woo! Did have a captive nut. But I've taken that off because there's a plastic insert here that's threaded, that screws inside the end and holds the end together within this. It's just a sleeve, which had a lip on it. So I took that off, unscrewed that, pulled that off, sanded, put it all back together again and sanded the edge. So I've got a nice smooth thing that just happens to be 15mm. Like I say, it's just brilliant the way this works out. And then, because the camera's working on, there we are, I'm going to glue that onto that, which is 15mm obviously, with some araldite. And then once that's set, I'm going to glue the plug, or the female plug, into the end, having connected it up. Isn't that perfect? It is brilliant. I can't recommend this stuff enough. And there we have it. Glue set. Isn't that lovely? A thing of beauty. Now, I've got no other excuses other than to grab the bull by the proverbials and try and upload the software. Coffee at the ready. Computer warmed up. And there is the scribbler. Perfect, just sits on the piano nicely, so I can now plug it in. Nothing like that when I first plug it in, because the Arduino hasn't got a sketch in it. So I'll get back to you when I've got something to show for it. It's about 2 hours later, and I finally got the light to light up, which is a fairly major step, considering it wouldn't compile at all. Kept coming up with some complicated error inside. I updated libraries, then the errors got even more complicated. But in the end, I updated the RTC lib library that enables the Arduino to, or enables you to read, write and control time, date and stuff like that from real-time clocks. And more searching said that it should be day of the week, not just day of week, which worked in the past. Heaven only knows why. I was very pleased also to find the top here. Where is it? No. Here. I've actually written some notes about calibrating it, what it should be and how to go about it. This is looking very good. I've just run another one of these calibration or checking functions that rotated it 10 times and explained that it should, after 10 rotations, end up exactly where it started off at. And look, it's still pointing at the 4th of April. That is fantastic. And there's proof, 4th of April, which means that the stepper motors and the gears and all sorts of myriad of other things are working as I hoped. Well, after much fiddling and trying to work out what on earth I'm doing to set the global variables or calibration things, it's written this. I thought I'd just go ahead and try Wednesday, December, I think it is, Saturday. So it needs to do a little bit more learning. The day at the top, well, it isn't Wednesday. I've been doing some more fiddling and it's all going very well, sorting out how to get everything where I want it to be, all the letters. So now it does this. I'm absolutely thrilled. I don't know what it is about this one, but you know, as I've said in the past, the one I built after the first one took ages to fiddle and tweak around with. Having used those few functions that I wrote to set this up, it's absolutely fabulous. I'm thrilled to bits.